Safe Software is pleased to present the 2009 FME International User Conference. This session is presented by Jared Sperry and Carrie Munks of Michael Baker Jr. Incorporated. Jared and Carrie are both proud Penn State Geography alumni and together have 17 years of experience in GIS. They both currently work as government contractors to federal agencies concerned with emergency preparedness.
So first we want to give you a little bit of background about our company. So we're with Michael Baker Jr. Incorporated, also known as Baker. We're very engineering and environmentally focused. We service local, state, and federal government agencies. Our corporate headquarters are in Pittsburgh, Pennsylvania. And we have about over 250 GIS professionals. And they're anything from analysts to DBAs to developers to managers. Jared and I are part of a team called the DFIRM Tools team, DFIRM being Digital Flood Insurance Rate Map. So we had a team of about 15 people, and what we were doing is we were creating customized GIS tools for FEMA's clients, and FEMA being the Federal Emergency Management Agency. And what it was to do is it was to help them create the flood maps according to FEMA's standards. So to give you a little background about how this, or for whom this application was built. FEMA's got a program called the National Flood Insurance Program, and what it does is it's setting the minimum regulatory standards for flood data, and it helps promote compliancy with that. And then with that, it has federally funded backed flood insurance based on that data. Under that program, there was a 5-year program called the Map Modernization Program, which we've also called MapMod. And what this was doing is it was transitioning from the paper maps that FEMA's traditionally used to a more digital format. So with that, they started standardizing their database, and they were kind of throwing the responsibility back to the communities to come up with their data. And it was also to promote efficiency and save money, because the idea is that once everything's digital, you can go back and revise it a lot easier than actual paper maps. So as part of the map modernization program, we were tasked with creating a continuous layer of the FEMA flood data. And this is called the National Flood Hazard Layer. It's the NFHL. And an aside, it was initially called the NFHL, but they were concerned it would be confused with the Football Association, because football and flooding kind of get confused in Google. So it's now the NFHL. And Baker, as being the national service provider, we were tasked with the development of this layer and also maintaining it. So to create the development of it, this is where we created that customized GIS tool set. So FEMA's mapping partners or other organizations could create these flood maps digitally, which is, again, the DFIRMs, the Digital Flood Insurance Rate Maps. And of course, there's this ongoing effort that as flood data is developed and it goes effective, it's constantly being revised because, of course, the topology of the landscape can change, and you've got to keep reviewing that so you can continue on with the flood insurance program. So before we started with FME, we were managing the data in separate databases. We had a public viewer so people could actually see the data. However, it wasn't kept up to date. There was no standardized time frame for when it was going to be, when the effective data would be added in. So it became very confusing to anyone who wanted to use it. And it wasn't reliable because you had no idea when the data was actually coming from, and if you were looking at the most effective data or not. There was also no real-time data extraction. So what you actually had to do is you had to find your data and then contact this other agency, order your data, and they'd burn CDs and then they'd send them to you. So it was obviously not an ideal process. So when we started integrating FME with the NFHL, we have 2 different databases we had to be concerned with. First was the production database, and this was the database where the flood data was actually being worked on, and any of the revisions were being done there. And this is where the DFIRM tools, that customized tool set, was being used. This database was an ArcSD 8.3, and it actually still is. And it's in Oracle 9i. So we ran into things where FEMA decided that 8.3 was still the best route to go even today. And this is accessed through these ArcGIS 8.3 custom tools. We also had the MapViewer database, and this was what was being available to the public users to view that flood data, to make any of their custom maps, and then to, of course, find any of the data they wanted for distribution. And this was being maintained in ArcSDE 9.2, Oracle 10G. And it was accessed through ArcIMS 9.2 and published KMZs. Now, another thing we had to worry about was FEMA gave the DFIRM tools to the mapping partners to create their maps, but they weren't required to use those. So if you were a person that wanted to use create your own custom tool set, or just sit there with the FEMA specifications and have at it locally, well, then you had the freedom to do that. So we still had to worry about not only getting that data also and incorporating it into the map viewer. So it wasn't just these two databases. There was additional data that had to be accounted for.
So building on what Carrie was mentioning about our two databases, this is our basic architecture of our environment, where we have our 8.3 database over here, which again is accessed by our customized tools. And that's a version database where users are creating version of that SDE database, working on it, and then we're posting that version back to the default layer. In order to get that 8.3 data to the public viewer, which is stored in 9.2, that's where we implement FME. And we implemented a process we would call replication, which is used somewhat freely in the industry. But we would take that data, and along with pushing it to an upgraded 9.2 database, we're also updating the schema on the fly, which is primarily where FME plays the role. You can see here the 9.2 database is primarily used just for viewing. There's a public viewer where anyone can go and view the FEMA data. It's published to a KMZ through ArcIMS, like Carrie mentioned, and we're also extracting that data for public distribution. Some of the key tasks, again, with FME are the schema changes that are occurring during that replication process. The data we receive from mapping partners must be converted to our production schema so it can be loaded into our 8.3 database. And when we replicate, that production schema is then converted back to the FEMA final schema. So you can see we're going from one to another, back and forth quite frequently. During that replication process, we're also identifying and trapping any invalid geometries that might exist in our 8.3 database or might exist in that source data we get from the mapping partners. And we're trapping those features, basically fixing them on our end just by the object ID. If it's multi-part features, we'll just explode them in ArcMap locally and try to load them again. We also use FME for some of the low-level statistics. If we want feature counts of every layer we have, then we'll throw together a quick FME workspace just to analyze all the layers and produce a quick report. In terms of the data we receive from mapping partner, we would prep that data using FME. So we would start with shapefiles. We would convert those to just a personal geodatabase and run those through an FME workspace that's converting that schema to our production schema so it can be loaded into our production database. Just a quick note there about the time that FME has saved us. We started this process with a bunch of custom tools that would be loaded into ArcMap 8.3, just DLLs and extensions. And some of that process, for large data sets, roughly 100,000 features or so, or a couple 100 megabyte personal geodatabase, that could take up to 6 hours to process that data. And now it's been cut down to just a few minutes using FME just to load that data into a personal geodatabase. This is our primary workspace for prepping that data. And what you see here are all of the source feature types on the left, which, again, since we're using data that follows a FEMA standard, all of the input feature type names are always consistent. The schema should always be consistent. There's some variation there in something like a street type. Some mapping partners have a tendency to abbreviate street instead of writing out street. So we'll have to deal with those occasionally. But for the most part, the input schema and everything is pretty stagnant. So what we're doing here is we're creating, where did my pointer go? Here it is. These are our source feature types. These little branches that you see coming off here we're creating what we call lookup tables. So in a situation where water names are stored with water features, like your hydrographic data, we're taking those names and replacing those names with a lookup ID. So we're taking the names of all of the features that contain a water name field, we're writing those names to a table, and we're replacing those values in the spatial data with a lookup ID. And we use that in our production database so people, if they want to update a water name, they don't have to update every instance in the data. They update the lookup table, and then the lookup ID stays the same. So that's what we're creating here, right there, along these paths. And the primary, it's kind of, see if I can point it out in here. It's been a while since I looked at the workspace, but again, the major workhorse of this workspace is, I believe it's here. That's where we're doing our schema mapping. So we're referencing, we have our schema mapping reference stored in a Microsoft Access database where we're using CSV file. I mean, we've gone back and forth, really no reason to go one over the other from our end. But we'll run the data through the schema mapper. Anything that fails a schema mapper, we're trapping in just another Access database written at the same time so we can go back and investigate those features. And then, again, we're written back out here on the right-hand side, everything in the destination data set. Again, it's just a personal G database that's in our production schema. My little circle here, you can see, this is my first attempt at a custom transformer, and it wasn't anything special. It's just a process that's repeated for every layer. Every layer has a unique identifier field, and we're prefixing that attribute with a constant value per workspace, basically, or per data set. So this is just the unique ID field of every one of those layers prefixed with that value. And so I threw that into a custom transformer just basically for organization at the time. So once we have the data loaded, the next big part of FME was to replicate that data to our 9.2 public viewer database. And when we first did this, we tried to line it up with a whole database upgrade from 8.3 to 9.2. Of course, obviously now that process got stalled a little bit, so we were only able to upgrade the public viewer database, and the production database is still in 8.3. So given that process stalled, we still had to take all of the data in production and get it over to the public viewer so we could start our nightly replication from there. So what we did was we created an initial load workspace that copied roughly 9 million features from the production database into the public viewer. It was broken down basically by feature type because it was such a long process, and we didn't want to just let it run and run and run in case a server went down. So we broke it up by feature type at first, and any feature types that took a significant amount of time were further filtered by object ID ranges. So we just did chunks of object IDs for that feature type until it was completed. Once the initial load was done, we did continued maintenance with 2 workspaces that update spatial data and tabular data every night as needed. So this is our initial load workspace. What we see here is everything here, again, everything on the left is coming from our production database, so it's always going to be the same. The schema and everything is always constant. Right here, initially, I'm running it through a couple error trappers just to explode any multi-part features or identify any invalid geometries, and trapping those to just a log file, an Access database where I track the object IDs in case I need to go back and do any fixing. This is a feature type filter. Some of the feature classes like these require no schema changes to go from our production to the final schema, so they're written directly out. And then this again is the schema mapper that's taking the production data, running it through the schema mapper, and writing it and converting that to that FEMA final schema that we need in the public viewer. And again, the features that fail the schema mapper are also written to the same Access database where they can be further investigated. This bookmark down here indicates where I mentioned before during the prep we're creating those lookup tables with the lookup ID and the water name. Now we have to take that value and put it back on the features. So we're replacing that lookup ID with the actual water name or descriptive information that we created during the prep. There was a challenge associated with this, which we'll get to here in a couple slides. Just to kind of mention it briefly, we found that this was all developed with FME Workbench 2008, and we found, at least in that edition, that version tables in our 8.3 database were not supported by the joiner transformer. So what we had to do was take the data in our versioned lookup tables and copy that to just straight copies of non-version tables. And then we would read the data from the unversioned copy. So that, again, was the initial load workspace to get everything over. And this is our continued maintenance update workspace. And what's happening here is we have, you can see the only thing red is one feature type, and that's coming from a table that's stored in our database. And what we do is every one of these FEMA studies has a unique identifier called the DFIRM ID. And as the DFIRM ID or that study is updated, we'll add a record to this table that reflects that DFIRM ID, so we know that that has some kind of update that has to occur. And so what we'll do is we'll read that table. This process here, can't quite remember exactly what those are doing. I think it's just adding a timestamp or a date stamp or something to that record. And it's writing out here to an Access database. It just tracks, basically, every time we run this workspace, we'll track the DFIRM IDs that were read from the table and updated just for historic record. Now, these two transformers here are really doing the brunt of the work in this workspace. These are two ArcSDE querier transformers. And what we're doing here, the first one is sending an ArcSDE query to the public viewer database, and it's looking for DFIRM ID equals the variable from the table for each DFIRM ID. And what it's doing is it's performing a deletion on the public viewer database for every feature that satisfies that query. So essentially, we're removing that DFIRM from the public viewer. And as those features are deleted, the next step is to now another ArcSDE querier is then initiated to query the same DFIRM from the production database. So this is how we're removing it from the target, which is our public viewer, and now we're retrieving those features from the source, and then from here on out, from this point forward, everything is basically the exact same as the initial load workspace. So now we have our features from the production database. I'm going to trap them for any invalid geometries, run them through the schema mapper, filter them back out, do the table joins for lookup tables, and then write them back out, and then we're done. So we're doing a full deletion of that study in the public viewer and then replacing that with the entire DFIRM in the production database every time. And again, this is only run as needed as these updates occur on the production database. That would be when studies go effective or if they're revised through different means.
Okay, so Jared had already kind of gone over some of these challenges. The first one being the table joins with the versions tables not being supported in FME 2008. So that actually caused us to create another workspace so we could copy the version tables to the unversion tables prior to running the main workspaces. We also, because of the time constraints, we weren't able to assign a global ID to all the different features to actually track the deltas between the databases. So like Jared mentioned, what we had done was literally wipe out the data that was for that county and then, or wipe out the entire database and then replace it at the county level with all of the updates. We also ran into a challenge with the processing time. The initial testing of that load workspace within the development environment took 64 hours. The final load of the data took 40 hours after the database enhancements, and that was executed in our production environment. So just time in general, of course, was a challenge. So what we found the benefits of FME to be, where we had increased efficiency for data prep, loading, and data transfer. It was a very useful tool when reporting to generate statistics against the databases. We're also reinvestigating the current functionalities to see where the possible enhancements are. So it's also a good learning experience as we keep trying to improve things here. And a great thing for us was that it generated interest for other Baker projects to use data transfer and raster processing. So I know I mentioned at the beginning we had 250 plus GIS employees, but we have maybe a small handful of people who really know FME, and maybe a little bit larger of a handful that know it exists. So we're really trying to promote this amongst our clients where we can, and even within inside the organization. So moving forward, we're going to continue to evaluate newly discovered transformers to see if they can take the place of the current functionality. So again, we can keep improving things such as the Workspace runner versus including small workspaces in a bat file. Again, trying to improve efficiency here. We're also going to look into more efficient workspace building because now we understand the FME functionality better. We're pretty much probably about 2 or 3 years into FME, so I know a lot of the other presenters have a lot more experience than we do. So we're continuing trying to improve upon that, so we can continue to troubleshoot our workspace failures. And also, we're looking into, well, we're actually currently working on QC workspaces. So again, that's another learning experience. So we keep trying to move forward, and as I just mentioned, the development of those QC checks. So the way the contract is moved now is the map modernization program contract is over. It hit its 5 years of that contract, and we're now on a new contract called Risk Map, and we're doing some production work for that contract. So we've taken our own in-house tools, and we're continuing trying to improve it and use FME in our own in-house in-house production tools. And with that, we're looking into the QC because we found that to be the most efficient way that we can really control QCing the data and just really making sure that we meet all those specifications for FEMA, because as any government agency, those are pretty thick binders. So we like to get all that in there for efficiency. So, and we have to apologize right now because we don't have that banter of Don and Dale. So, so sorry for that. But ours was an intermediate session, and we think that that's the advanced skill. So, any questions?
Thanks, Gary.
Thanks.